You have no clue what the deposit is going to be. Question mark. You do know that the rate is 8.2559%. You know that the function f of x equals deposit times the rate raised to the number of years, x. And you also know that x equals the number of years since the account was opened. Which two items below would make a true scenario if the ending amount of money is $322,000, or I should say $322,275.83? Choose the closest answers. And you'll notice in A and B the choices are the same, so that's a glitch in the program. So either one would be right if it were 15. But this is the type of problem that you can see on a Common Core end of course exam. It is multiple choice. The only problem is it is multiple choice. So whatever you choose from the first column here, you must make sure you choose the right one over here that goes with it. And there is only one right combination of answers. So it is a trial and error. There is no one formula that will give you this right answer. But you can eliminate some answers based on the scenario. Alright, so if we start with a deposit that we don't know, and the rate is 8.2559. We know we multiply the deposit by the rate raised to the x power, which is the number of years. We don't know the deposit, we don't know the years. But if I start with an amount of money and end with $322,000 and some change, then must the amount of money that I started with be higher or lower than $322,000? It must be lower. So we can eliminate this, and this, and this, and this. That leaves us with this. So we've eliminated all other answers. We have $98,051.47. But now we have to figure out which amount of years will give us the deposit or the ending amount here. Okay, well notice we have 3 15s in there. That is an unbelievable glitch in the program, which I think I fixed after I had printed out these problems. But the first one is an example and it should be easy anyway. So let's try 15. If the deposit were $98,051.47, and we have to multiply that by the rate. The rate is 8.2559%. Now, it's not just the rate. It would have to be the rate plus 1, and then you're going to raise that to a power. So over here you should have the formula looking like this: deposit times 1 plus r, and then raise to the x power. So we have our 98,000 in the calculator. We're going to multiply that by the quantity of 1 plus. But it's not 8.2559. You have to change the rate to a decimal, which means move the decimal point 2 places to the left. We have just entered in 98,000 and some change for D. We have a parenthesis here, 1 plus, and now we're on the rate, which we are changing to a decimal. So 0.082559. Right hand parenthesis, and then caret. Insert 15. And see what we come back with. Is that the ending amount that is in there? Did you type in this amount? here that I am circling in your calculator, and hit the times button, and then a left-hand parenthesis, and then 1 plus 0.082559, right-hand parenthesis, a caret, and then the number of years, 15, which we are choosing from here. If you did that and hit enter, what did you come up with? You got the ending amount. So it's 15 years. And in this case, since we have 3 different items in here that are 15 in that column, you could choose any one of those and it would be right. Unfortunately, all of these problems won't be as easy as this. Alright, so we have the same type of problem next. You don't know the deposit that is being made in the bank. The rate is 6.9279%. The function to find the ending amount is f of x equals the deposit times the rate raised to the power of x. X is the number of years since the account was opened. Remember that rate must be expressed as 1 plus the decimal version of the rate. When you express the decimal version of the rate, you move the decimal point 2 places to the left. So which 2 items below would make a true scenario if the ending amount of money is $841,346.20? If I end with 841,000 and some change, then that means the deposit must be greater or lower than that. It must be lower. Are there any amounts in the deposits that are higher than the ending amount? No. So this will be the most difficult type of problem that you see of this type today. The previous, you had all of them but one that you could eliminate. But now you have to check each one. So you have to estimate and make an educated guess based on the percentage rate. Okay, so you saw what happened before when we had 98,000 and the interest rate was what, 8 something? And over 15 years it swelled up to like $300,000. So on this one we're going to end with 841,000 and some change. Could we start at 22,000 and some change and only go for 6 years and come up with this amount of money? No. I don't think that would be possible. Could we go, for example, at this amount of money for 28 years at 6 and some change percent? Would that take us up to only 841,000? No. So there are different things you can eliminate. You have 5 choices in the first one. You have 4 choices in the second one. You have 20 different possibilities that you can check out. If you are unlucky and don't eliminate some of these, like we just eliminated those 2, then you would end up doing all 20. If you can eliminate some possibilities, then you may only do 18 like we've just done. So what you have to do now is to go through there and use this formula. F of x equals your deposit times the quantity of 1 plus r, close the quantity, raised to the x power. And you have to choose a deposit amount, put it in here, and then change your rate. It'll be the same each time. Or no, you have to change it each time you put it in, 2 decimal places to the left. And then the number of years here. The rate is going to stay the same. You just have to move the decimal point. But this and this is what you have to keep plugging in and checking. Do that now and see if you can come up with the right deposit and the right years. On the practice problem, the right combination should be the following. The deposit should be A, and the number of years should be C. On this problem, you don't know the deposit. You know that you end up with this here, and that this is the rate. Well, if you end up with this, what you started with must be before that. So this, they're all before this. Before this one. That's kind of close. Do you think that over the course of maybe 10 years that you're going to go from 535, 574, 64 to 535, 449, or and vice versa between those two? It looks like the space between those two would be so small that there's no way you could take that amount of time on the right, any of those, to make that leap. So you could probably eliminate that one. What about this one? Is that too small to take 16 or 18 years at 5% to make it up that high? Yeah, so you can eliminate that one as well. So if you eliminate that, anything that you eliminate in the first column, that takes away 4 different times you would have to try calculation. So there's 8 things you don't have to try now, because for each of these you may have to try 4 of those. Okay, so now it's an educated guess from this point. You have 2 that are close together. So if you try one of those going through here, you might be able to either assume that it's that one, or maybe the other one, or eliminate both of them. If you try either of these, you're going to see a pattern that suggests that no matter what amount of time you have on the right, it's just not going to work out. So C is the right amount of time. And if you choose C, eventually you will figure out that the right amount of time is 10 years. C and B.